We will be talking about the management of the rainfed production systems in India to enhance the productivity and profitability. As you know, that water everywhere. Like if we talk about the uh, availability of water, the drinking water, then only there is some issue. Otherwise, we don't feel any that there is any deficiency of the water because uh, and if you see the global map of the scarcity, can you see my cursor?
Yes, sir.
Yeah. So there are some uh, dark spots on the map. Then there are some no little water scarcity maps. So where is India? We are either on the physical water scarcity region, or we are either like approaching towards the water scarcity, or in the economic water scarcity region. And if you see the global maps, majority of the western halves of the continental land masses are having these. If you see the map below, the yellow colors, it means the water scarcity regions. So the of course there are some geographical regions for water scarcity. We can discuss later on that, but yes, a sizable proportion across the globe is now facing the scarcity of water. And if we talk about the agriculture per se, more than 80%, precisely being 82% of the global agriculture is rain dependent. And if we talk about our country also, India, more than 50%, even after the planned development of Indian agriculture, if we talk about after independence, though we have tested the fruits of green revolution, but mainly it remained confined to the our irrigated regions. If you see, since last 3 to 4 decades, our growth rate of Indian agriculture remained little more than 5% in the irrigated regions. But if we compare the rain-fed counterparts, it remained little less than 1%. It shows that there is a huge difference in the two ecologies. And if we see this map, majority of our region, like still either they are rain dependent, or if the irrigation facility exists, that is also limited, barring these endogangetic plains and some of the areas of the Krishna, Tungabhadra and Kaveri Delta region. Majority of the other regions are by and large are mainly rain dependent. So Jagjit Singh has raised the hand. You can ask in the at the end, or you can write on the message box. So this is the scenario. Like we are having more than half of the area, and it is home for nearly 40% of the humanity and 60% of the animal population, and it provides food. Like more than 40% of the food comes from the rainfed regions. So yes, definitely there is a need to look towards the rainfed areas also to enhance their productivity, so that the farmers of these regions can also survive well. They can also reap the benefits of the agriculture, that green revolution or blue revolution or white revolution or whatever different rainbow revolution, so that at least they can also get benefits. If we see the yield gaps of the drylands, so the observed yield and the farmer's yield and the achievable yield, there are huge gaps. And if we compare with the our neighboring countries and other developing countries, we are not at very good stage. There is a huge gap exists, and it is across the different crops, be it the legumes or be it the millets or whatever. Everywhere the huge gap exists. It means we have to focus on all the commodities, agricultural commodities, majority of the field crops, and in the different ecologies where we are cultivating the crops best primarily based on the rain either or the what if the irrigation facility exists, it is very limited. So this is simply comparison how the rainfed areas, the status of the farmers in the rainfed and irrigated areas. So majority of the data indicates that there is a severe poverty. The socio-economic conditions of the farmers of rain-dependent regions are not that good. And if we categorize all these problems, then there are three categories of problems. One is the environment, weather, and climate-related problems, like late onset or early withdrawal of monsoon, or the dry spells in between, or some other adversities related with uh, the weather. Then there are some soil related problems like nutrient deficiency or the erosion or runoff or maybe the problematic soils. And the third one and the most important is socio-economic problems of the farmers in the region. So their capacity to adopt the new technologies is limited. Their risk bearing ability, that too is very less as compared to the farmers of the irrigated regions. So we need to take care of that those socio-economic situations also while working for the drylands and while recommending or coming out with the findings for that reason. So it should be fit for the socio-ecological conditions of the farmers also. So like entirely we cannot manage the climate. Like it is very difficult. Some of the things we can manage through various agronomic management technologies, and the soil related technologies we can manage in a better way if we plan the things in a nice manner. So we will be discussing those things, those technologies in the coming slides. Uh, so, and if I categorize, the three things are important in the rainfed regions. As the moisture is limited, so therefore, one thing is collection of the water, whatever way, maybe the rainwater harvesting can be the best solution, uh, and its reuse for the supplementary irrigation or the life-saving irrigation can be the best way to advance. I'll share at the end one success story, a big success story. Also, if the time permits, uh, I was reading one message also in the chat box. So the collection of the rainwater, then conserving the water, whatever water we are having, conserve it. It is not that simply the collection is important. Conserving the moisture, it doesn't cost much. So I'll be talking about the technologies which are not much costly because farmers are already very poor. They cannot afford to go for the expensive ones. And then efficient utilization of the available moisture is the third key thing which we will be talking about in the coming slides, right? So you are ready to manage the drylands? Say yes. Say yes. So I get,
Yes,
I
yes,
have
sir.
got,
Yes.
yeah, I have got
Yes, sir. We
several
all are
yes.
ready.
Okay, good. Yes. So I'll come to this. Number one is bund making. I'll bring this one first. Bund making. Can you see the bunds? When your fields remains fallow, simply raise the height of your bunds so that whatever rain comes. Have you heard that proverb? खेत का पानी खेत में, गांव का पानी गांव में. Means don't allow the runoff water. Whatever water goes as runoff, जितना भी पानी runoff जाता है, that should go only after once your bunds are filled and once your water is like fields are full. So that at least when you sow your monsoon crop, the Kharif season crops, you should have sufficient moisture to survive the crop for a longer period. So very cheap technology. Farmers, in a way, they can increase the height of their bunds. Doesn't cost much. कोई खर्चा नहीं लग रहा है, ज्यादा लागत नहीं लग रही है ना. And then you are keeping the water here, you are maintaining sufficient moisture. Development of the watershed areas so that you can reduce runoff. You can recharge your groundwater, or you can make some check dams or small dams or farm ponds or something like that, so that you can enhance one your groundwater level. Number two, you can use this water when there is no moisture availability of the crop and the crops are dying, as a life-saving source, life-saving irrigation source. It will be a surprising fact. Friends, do you know which region of the world receives greatest of the rainfall? दुनिया का कौन सी जगह है जहां पे सबसे ज्यादा बरसात होती है? Who will tell? Yeah, I got the answer. Mohsin Ram, Cherrapunji, northeastern India, Garo Khasi Hills. Yeah, very good. I am very excellent. So that is the region where we receive the greatest of the rainfall of the world. But if you see, even for your surprise, for most of you, your Mohsin Ram or your Cherrapunji also faces drought for some part of the year. उधर भी सूखा पड़ता है. Even sometimes they feel like deficiency of even drinking water sometimes during some of the years, because they receive lot of rains during the rainy season only. Post rainy season, sometimes they may not have sufficient moisture for the post rainy season crops, specifically maybe after the by the end of the Rabi season sometimes, and by maybe post Rabi season. So that is the problem. Yes, I'm getting very good response. Yes, and of course, the one reason is that there are some suggestions from the students. I would call you if there is a faculty. Please forgive me. Yes, I'll use the term students. So from the students that there are sloppy lands, you cannot um, store the water there. But yes, of course, you can go for like bund making, or I'll be talking about some other technologies in the later slides. Then putting the harvested water directly into the wells, which means specifically in the limited irrigation, limited rain regions, or the areas with less than 1,000 millimeter rainfall. If you have seen that 100 centimeter ISO, uh, that 100 centimeter rainfall region, uh, the less than 1,000 millimeter of the rainfall region. So there, your water harvesting and putting it directly into the wells is the good technology. Why? Because the groundwater level in majority of that region is very deep. Sometimes maybe deeper than 10 meters, 20 meters, or maybe more than that. So for those regions, it is very difficult to increase the groundwater levels with the other methods. So put it directly into the wells by some constructing some cheaper uh, technologies. Then yes, of course, soil erosion is one of the biggest problem of these regions. So strip cropping to reduce the erosion by erosion permitting crops followed by erosion resisting crops. And farm pond farm pond concept, though it is as such the concept is very old, but it is getting popularity now in the recent times, maybe past 2, 3, 4 years, specifically in the dryland areas of Rajasthan and adjoining states, where the farmers are adopting it in a big way now. They call it diggis or talab, khet talai or something like that. They are harvesting the rainwater and reusing it for the supplemental irrigation. And yes, of course, this water should be used as efficiently as possible. Maybe at the critical stages, don't apply it, don't waste it, use it at the critical stages, and that too with the efficient methods. So these are some of the research findings. I'll skip those the findings, but the conclusion here is the application of the limited water at critical stages of the crop growth increases the yield in a much better way than applying the water at non-critical stages. These are the findings from across the different parts of the region and on different crops. Can you name this machine? Laser land leveler. It is written here. Laser land leveler. Yes. When this machine was first introduced in India in late 90s, it was not adopted by farmers very readily. Like many of even the well-educated people were also having their reservations that the farmers cannot go for computer land leveling, and the farmers literacy rate is like they were having their own points like literacy rate, poverty, and the some other reasons. But those who are from the Indo-Gangetic plains, Haryana, Punjab, Western Uttar Pradesh, those who are from this region, they know that now this leveler has covered like almost every field. पंजाब, हरियाणा और पश्चिम उत्तर प्रदेश वाले आपको बता देंगे कि ये वाला जो मशीन है आज हर खेत तक पहुंच गया है. Every field this machine has covered, and now farmers are labeling their fields. And benefits of leveling, they have enhanced their water use efficiency. So water is the most precious thing in the dryland areas, and Yes, mostly in Punjab, but yes, farmers of Uttar Pradesh and Haryana are also not behind. They are also using it widely. And that time it used to cost around at like maybe nearly 20 lakhs or so. But over the years, since the technology has spread, now it is being manufactured locally. So that is why its cost is also nearly 2 or 2.5 lakh or so. So the cost has cut drastically. And through using this laser land leveling through laser beams, I'll not so the I'll not tell much details, but yes, through that uh, we can enhance the water use efficiency to the great extent. Then plantation of the trees, use of mulchage and conservation agriculture. I hope by now, like if you go 10 years before or so, then nobody was aware much about the conservation agriculture. But now everybody is talking about conservation agriculture. So conservation agriculture means not tilling the fields. So that is why reducing the diesel cost. Not tilling means the preparatory tillage is completely avoided. Only sowing is done. So only single operation and retaining the crop residue, retaining the residues of previous crops. So no residue burning. Crop residue burning is completely avoided. That जो पराली जलाने की बात कर सुनते हैं वो उस समस्या का भी समाधान हो जाता है. होप यू आर गेटिंग मी. सो दैट क्रॉप रेजिड्यूज वी आर नॉट बर्निंग, सो दिल्ली का पोल्यूशन कम हो जाएगा ना. एंड देन क्रॉप डाइवर्सिफिकेशन is the third component of the conservation agriculture. And for the rainfed areas, it is a excellent technology because why? Other than the benefits of the diversification and the residue burning solution, you can conserve the soil moisture also. So that conserved soil moisture through the mulching increases the crop productivity and it reduces the weed growth. See, there are no weeds in between the rows. So weeds, they transpire more water. So that is why the crop is like getting more moisture. And then, of course, contour farming and other technologies can be used in the slopy lands. वो मोसिनराम वाला कोई बोल रहा था ना, because of sloppy lands. So that thing you can take care of through the contour farming practices. Yes. So as I said in the previous slides, here there are no weeds. So now I'm talking about integrated weed management aspect to conserve the soil moisture. Why weed management is important? Because the transpiration efficiency of weeds is 3 to 4 times more than the crops sometimes, or maybe sometimes even greater than that. The nature, जो प्रकृति है, has given the weeds the power to survive under the moisture stress conditions also. So they can transpire more, their transpiration efficiency is also more. Then, yes, of course, deep summer plowing is the another technology in addition to increased infiltration rate, infiltration capacity of the soil. It also controls several pests and diseases also which are hiding inside the soil. So soil-borne pathogens, the pupae and larvae of the insect pest can also be controlled through deep summer plowing. And then planking to reduce the moisture losses. So these are some of the technologies which you can uh, apply in the rainfed regions to conserve the soil. Then your breaking surface layer, specifically for the hand weeding, I would say, जो हाथ से निराई गुड़ाई करते हैं उसके लिए बोल रहा हूं मैं. you break the surface layer so that this capillary loss of water can be avoided, right? And meanwhile, you are uh, killing your weeds also at the same time. Then you are also increasing the aeration in the root zone of the crops. आप ऊपर की पपड़ी तोड़ने से मृदा नमी संरक्षण तो करते ही हैं, खरपतवार तो नियंत्रित करते ही हैं, परंतु साथ ही आपकी जो पौधों की जड़ तंत्र है उसमें वायु संचार भी बढ़ा देते हैं. एंड बिकॉज ऑफ दैट the strong root system can extract more moisture and more nutrients from deeper soil layers, and that is how the crops in the rain-fed regions can perform better. So that is the key message here. Hope you are getting me. The mulching, I'll not discuss much about mulching because everybody, like, it is very popular technology for drylands. So mulching, you know, its benefits. Uh, yes, of course, spray of potassium. You know, potassium is known to enhance the drought tolerance. It is linked with the stomata opening and closing, the turgidity of the guard cells. So that is why if we spray पोटेशियम, 0.5% पोटेशियम का छिड़काव कर देते हैं फसल पे ड्राउट के टाइम, it minimizes the wilting symptoms during the drought period if you go for the potassium spray. Second one is removal of older leaves which are no longer contributing for photosynthesis. You can remove them. You can use to those leaves for fodder or for the mulch. As a mulch, you can apply on the surface. Then optimum plant population, of course, and organics we will be talking about more in the coming slides. Why organics are important? Can you tell me why organics are more important in the rain-fed regions? Number one, because what? The particle size of organic manures is very less, even lesser than clay particles sometimes. So it enhances the surface area of the soil. And because of the increased surface area, the soils retains more moisture in it. And of course, there are some other measures like mid-season corrections, making certain other plants. And yes, the Pusa hydrogel, the IRI technology is also becoming very popular in the drylands, where we are applying 2.5 kg of the Pusa hydrogel in the root zone of the soil. For its application, we use the field of the same, the soil from the same field, say maybe 10 or 15 kg of the soil from the field itself, and then mixing the hydrogel in it and putting it into the root zone. So what does the hydrogel do? When there is sufficient moisture, it absorbs the moisture, extra moisture, 300 to 400 times of its weight, and it releases the moisture back to the plant when there is moisture stress. So for a few days, plant survives more. So like if there are some dry spells in between, your crop will not die for next 2 to 3 weeks. So that is the basic objective of this polymer. And of course, there's anti-transpirants, cheaper anti-transpirants like kaolin or cycocel. They are also very excellent interventions for the dryland areas. So this is about hydrogel. I'll not talk much about the detail, but yes, it can work well in all the agroecologies, specifically for the arid and semi-arid region of India. And Other things I have talked about, but yes, it remains stable in the soil at least for a season or sometimes for 1 year. So these are some results of the research which is carried out at IARI. Effect of different gels. This is about gel Shakti, earlier gel. And these are some of the transpiration suppressant, anti-transpirants, which either increases the reflectance of leaves or reduces the size of the plant, or anyhow it helps in reducing the transpiration so that the moisture in the field can be conserved. So this is about the transpiration suppressants, and as I said earlier, the cheapest is kaolin, which is a reflective type. Other than kaolin, lime and atrazine sometimes, though it is a herbicide, but in the lower quantities, this can also act as the stomata closure, uh, and then certain other transpiration suppressants. So this research carried out a IARI on palmate mustard system shows that the various transpiration suppressants not only increases the water use efficiency and the productivity, but it increases the it improves the moisture extraction pattern also by increasing the root growth to the lower level, lower region of the soil profile. So by the in a way it also enhances the capacity of the crop, where the crop's root zone is also gets increased. So that is the important message from here. The another study from the same institute says that uh, yes, they are effective in the legumes also, where they enhances the productivity and water use efficiency, and in some other crops, palmate, pigeon pea. Uh, so the key take home message is that transpiration suppressants are yes effective for majority of the crops which are grown in the dryland. And now, how efficiently utilize the moisture which is available, whatever moisture we are having, utilize it efficiently. So the selection of a variety matching the rainfall pattern and matching the farmer's socio-economic setup is important. Yes, very good response I am getting in the chat box also. Even some of the things which I have not said, uh, the the students are suggesting me that yes, it improves the soil physical properties, etc. So good. Thank you for your very good suggestions. And now the participants have reached to 1,000 triple nine. Excellent. So choice of the varieties in drylands and the criteria are shown here. What are the criteria? So these are listed here. Nothing much important, but the thing is the only key here is key message is it should be matching your socio-economic conditions and your rainfall pattern. Next. Other than this variety is the land configuration measures like raised bed, ridge and furrow methods, and the other technologies can be also of much use. And fertilizer management, nutrient management in the uh, Rainfed is very important. Sometimes what happens in the rainfed areas, you may see the nutrient deficiency symptoms in the crop. But even then, you cannot apply the fertilizers. कभी कभी बारानी खेतों में ऐसा होता है कि आपके फसल में पोषक तत्वों की कमी के लक्षण दिखाई देते हैं, फिर भी आप उनमें फर्टिलाइजर नहीं डाल सकते। बताओ क्यों? बिकॉज there is no sufficient moisture. If you will apply the fertilizer specifically for the standing crop nitrogen, so what will happen? Once you apply the nitrogen, it will enhance the growth, and once the growth gets enhanced, it will take more moisture, and already there is deficiency of moisture. You will not be able to your crop will not be able to survive rather. So for such conditions, the foliar spray of the nutrients, specifically the nitrogen fertilizer, is a good strategy where you can go for 1 to 2% spray of urea or 0.05% of the thiourea, or in combination with your potassium, 0.5% of potassium, and now liquid fertilizer which is becoming very popular nowadays is your nano urea, nano DAP is now coming, nano zinc is also there. So these are the new fertilizers which are coming. Maybe some of the farmers are very happy with the nanos, some may not be. So that is a different issue. But yes, the foliar spray can be a key technology in the rainfed regions. Then your land configuration, ridge and furrow, broadbed and furrow, and some other technologies, compartmental bunding. So these can also help in saving more moisture in the root zone and using it. Then I'll skip these research findings, which indicates how efficient these land configuration technologies are. So again, deep plowing and this is also one very good technology for dry lands, aqua sowing. In aqua sowing, specifically in the post rainy season, मानसून के बाद का सीजन, though the moisture availability is there in the deeper soil layers, but in the upper soil profile, there is huge depletion of the soil moisture. And in that case, if you go for sowing of the post-rainy season crops in the rain-fed conditions, you will see that there is no germination of the crops. So to facilitate the germination, to hasten the early root growth, a solution of 1 to 2% of urea or DAP in the form of water, nearly 15 to 20,000 liters of water per hectare at the time of seeding. So there are the water is poured along with the seed in the seed drill, and you observe that there is sufficient moisture in the root zone for germination at least. And since you are getting the readily available nutrient solution also along with the seed, so this solution facilitates the germinating seedlings to quickly grow their roots. And when the roots reaches to the moisture in the subsurface zone below this maybe little below the surface where there is sufficient moisture, then crop can grow. For some of the areas, you can even you can go for double cropping in for through such technology. So it is very useful one. And then your seed treatment, seed priming. These are some of the other methods with water or potassium nitrate to for the quick germination of the seedlings, and then owing to quick germination and the early root growth, the 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 root reaches to the moist zone, and that's how the crops can survive. As I said, the organics are very important for the dry lands, and the application of vermicompost or farmyard manure and compost can not only increase the fertility of the soil but also the water holding capacity. And since the cell shape of the green manures, specifically your dencha, sesbania, is acidic, its pH is less than 5. So acidic pH, if you incorporate the dencha crop inside, it reduces the pH of the soil also. So for the high pH range, and of course, yes, in the rainfed areas, majority of the rainfed, the dry lands, specifically rainfed dry lands, the pH is very high, and pH related problems comes in these regions. So the green manuring can be a win-win situation for them, as it reduces the pH of the soil, it provides the nutrients, it increases the organic matter, it improves the soil physicochemical properties, biological properties. So many benefits through one technology. And this is about the how the organic sources can be better. So if, specifically in the low moisture availability regions. So though it is in detail, but here the key message is that organic matter, because of the increased surface area, improvement in soil physical properties, it provides moisture to the crop, owing to the increased uh, water holding capacity of the soil, and because of the increased water, the nutrient availability in the moss flow also increases, and that is how the crops get better moisture. And due to the better moisture, there is, like, obviously the yield increase will be there. The You can cut the cost of fertilizers also, as the it increases the availability of the nutrients. And yes, mycorrhizal, I'll talk about the mycorrhiza in the later slide. So I'm skipping this as of now. Placement of fertilizers, yes, near to root zone is also, though it is important for all the cropping systems, but for rain-fed areas, because specifically for phosphorus fertilizer and other nutrients also, the movement of the nutrients is very low because of the moisture scarcity. So if you place the fertilizer near to the root zone, then maybe there is 5 into 5, there is one formula, 5 centimeter to the side and below 5 centimeter below the seed. So there, if the nutrient is available, on account of germination, once the root goes just 5 centimeter, that is 2 inches nearly, it is having its nutrient source, उधर इसको खाना मिल जाता है, and once it gets its food there, the initial growth is better. And once the growth picks up, the crop is happy for the entire period because of the better root development, better crop growth in the early part of its ontogeny. So then of course, yes, balanced fertilization, because only nitrogen fertilizer or only phosphorus fertilizer will not work here. Um, yes, I'll share the slides, no problem. Or this presentation is available on my ResearchGate also. You can search there also. RS Bana, if you type on the ResearchGate, or simply you type on Google RS Bana ResearchGate. So presentation is available there also. So you can download it. It is available online. So those who are requesting this presentation, it is for them. Uh, so since the time is about to end, so I'll skip these slides. Here the message is Sam. So now AM Panjai, the WAM or AMF for drylands. It is excellent biofertilizer as the IP network enhances the rhizospheric area. One, then the IP absorbs or helps the crops absorbs more nutrient from the soil and transport it to the plant system. So that is why the WAM biofertilizer is recommended. Other than that, of course, these rhizobium, azotobacter, azospirillum, these are some of the sources for nitrogen and the phosphobacteria. And nowadays, many liquid fertilizers, the consortia of the nutrients or potassium solubilizing bacteria, zinc solubilizing biofertilizers are also coming up, and many of the farmers are using it. Liquid biofertilizers are in demand nowadays. So, and one more thing, I'll since we are talking about the microbiology and the biofertilizer. So, Pusa decomposer, I would like to mention here, though it is not related with this presentation, but yes, Pusa decomposer is also one of the technologies related with the bio microbes, where you means like farmers are using it for uh, decomposition of their crop residues, especially in the rice wheat cropping system to decompose the rice. The Pusa decomposer is becoming very popular. Yes, slight modification in the fertilizer application timing and the dosage is required as per the availability of the moisture is required in the drylands. So that is also specific. I'll share the slides. So the detailed information is given here. Uh, then water conservation practices are also like water deficiency is a perpetual problem and the biggest constraint for adoption of fertilizer use technology, and all the measures should be adopted to harvest every drop of rainwater in the field so that we can enhance the native plant nutrients and then obviously the crop growth. I'll skip this crop residue recycling as the residues. We have discussed this about the residues earlier in the mulching part also, and the conservation agriculture part also, and in the Pusa decomposer. But yes, the use of crop residues enhances the nutrients of the in the root zone. It conserves the soil moisture, I would say, and reduces the weed growth. So nowadays, residue recycling is becoming uh, popular and it is being advocated by various research institutions. So that is the message here in this slide. And based on the deficiency symptoms on the leaves, like if you see the deficiency symptoms here, this picture is clear cut. Lower leaves, middle leaves, upper leaves, and the color of the leaves, purple, yellow, spots in between on the middle leaves or lower leaves, or veins are green or not green. So based on these symptoms, you can identify which nutrient is deficient, right? Nitrogen is deficient when lower leaves are yellow. Likewise, the other nutrients you can identify, and based on that, you can go for foliar spray of the nutrients. And as I said earlier, also foliar nutrition is relatively more important in the drain-fed regions because one uh, in the soil solution, the mass flow is less because of the low moisture in the soil profile. But yes, you can directly here you put the nutrients in the on the leaves, and the plants can absorb through the leaves. So that is the advantage here, and the nutrient use efficiency is far greater, particularly for the micronutrients, the zinc and iron, mainly. The fertilizer use efficiency is less when you go for soil applications. So foliar feeding is better in those conditions. These are some of the findings on foliar nutrition effects. This is ammonium thiosulfate. So sulfur nutrition through foliar fertilization, and moisture conservation effects through the conservation agriculture, no tillage with crop residue management, and conventional tillage. So the yield is greater when you go for crop residue management and when you go for foliar application. So recommended dose of sulfur is nearly at par to the twice application of the ammonium thiosulfate. It also enhances the nutrient content. So it adds to biofortification of the product which are uh, coming in the market. So the more quality food you can go get if you go for foliar spray and for moisture, the conservation of the soil moisture. So dual advantage you are getting here. Some other findings where you can see the increase in the nutrient content in the end product, that is the pulm millet and in the chickpea. These are some of the field photographs, the work carried out at IARI. And then one more technology I would mention, if the time permits, that is high density palm millet planting followed by alternate row harvesting. So farmers can get the fodder for green fodder for their livestock, as the livestock is important part of the cropping system, specifically in the low rainfall areas. So there you can generate extra green fodder while getting almost equal or sometimes better yields as compared to the normal planting density by applying a little extra fertilizer, nitrogen fertilizer, that too. So without increasing much cost, you can get the additional green fodder and more yields. These are the effects on various soil properties, nutrient uptake, water use efficiency, and the soil parameters and microbial activity of the soil. So I'll skip these effect, and I'll come to the another advocacy. If you see this picture, there are so many engines put. You are wasting the water like anything. So instead of going for flooded irrigation and wasting of the water, go for the new technologies like what? Sprinkler, drip, rain gun, so that you can enhance the water use efficiency, use less quantity of water and get more yield. That is more crop per drop, as Professor Swaminathan has mentioned rightly, uh, and enhancing the yields and the better quality. And the new technologies are suitable for majority of the crops, maybe for different land use systems, like including agroforestry and the undulated topography also. Though initial cost, ये नोट की गड्डी दिख रही होगी आपकी, हालांकि पैसा पेड़ पे नहीं लगता, बट यस, there are some certain government schemes and subsidies and loans are available. So farmers can approach for try for these facilities, and then of course need based herbicide also you can go for, in addition to the other, since most of these things I have discussed already, so I'll be talking about herbicides now. So if you want to use the herbicidal, go for herbicidal weed management, then there are options for drylands. Majority of the herbicides which are used for the irrigated ecosystem are equally good for the dryland. So, and the for drylands, only thing is at the early stage, if you control pre-emergence application of herbicides, I would recommend, because at the early stage, if you control the weeds, the initial growth of crop is good. Once the crop picks up the growth, then it can take care of the weeds later on. So early pre-emergence application is more important in rainfed regions. And of course, yes, then your contingent crop planning and other policy support is required, like subsidized input, local specific contingent plan. Now it is available for all the districts, thanks to the efforts of the ICAR and its NICRA project. Uh, it is available on the website of NICRA and your CRIDA Hyderabad, the Central Research Institute on Dry and Agriculture. So contingent plan for every district, based on your rainfall pattern, your local needs of the varieties, and your local market demands of the varieties. So these are the things, and the promoting water harvesting and the dry land practices is important, other than the modern method of managing the water, managing the nutrients, and managing the crop. And of course, yes, crop diversification and enterprises diversification is the key in the, specifically in the rain dependent regions, as it ensures year-round income of the farmers. So diversifying the existing cropping systems and farming systems of the farmers, and adopting the crops, including horticultural crops, which are suitable for your area, going for the medicinal plants and cash crops like Google, Sarpganda, Isabgol, cumin, etc. for the extreme, even for extreme drylands, that arid regions, and fruits like amla, date, bear palm, date palm, bear, falsa, and several grasses which are perennial in nature. So these are some of the options to diversify your existing systems for the drylands, which are more remunerative and easily adoptable. And of course, your एकला चलो वाला नीति ज्यादा काम नहीं आएगा. Go for community-based watershed management. Involve your other friends, stakeholders, villagers, for like going for adopting these technologies, including water harvesting, in a community basis. Your community pond, community harvesting, etc. So with that, I'll end it here with the concluding remark that yes, water is of course very precious in the drylands, and therefore we need to adopt a comprehensive approach to conserve the moisture and use it as efficiently as possible. Then the second is select suitable crops and their varieties for the recommended for your region, and then adopt the cheaper technologies like deep summer flowing, etc., for taking advantage of the early rains and enhancing the infiltration capacity of your fields. And then surface covering by mulching to reduce the evaporation losses and the weed growth. And the planting techniques which are suiting to your conditions so that you can enhance the water productivity and the crop productivity both, and with the hope to bring more spoils, with the wishes to bring to increase this the smiles on our farmers faces. I end it here. Thank you very much.